I'm Maria Doneva and I'm part of a special educational program Young and Adult Geniuses created and in ownership of AQ Excellence Company, and I will guide you through the pages of this amazing book, How to Be a Genius, written by John Woodward. Let me give you a short contest. Meet your brain. Come to your senses. How memory works. Problem solving. Away with words. The creative mind. Your brain and you. The evolving brain. Your amazing brain. The brain is the most astonishing part of your body. Its billions of cells control everything you think and do, including your actions, senses, emotions, memory, and language. The more you use it, the better it works. This book is all about how to get your brain cells buzzing and maybe become a genius. Emotions. Fear, anger, joy, love, and other emotions might seem like automatic mental responses, but we can use our brains to control our emotions if we want. Automatic activity. Your brain is always active even when you're asleep. It also keeps you alive by controlling your heartbeat, temperature, breathing, and digestion. Perception. All of your senses are wired into your brain, which takes in the signals they send and allows you to see, hear, smell, taste, and feel the world. Thinking. Your brain is always solving problems by connecting different ideas, even when they are not part of your own experience. Only humans can do this. Memory. Every event or fact that grabs your attention may be stored in your memory, an amazingly efficient library of information that never runs out of space. Language. Your brain gives you the ability to communicate and understand complex ideas using speech. You can also learn by reading words that were written long ago. A human brain is the most complex structure on Earth. Movement. Your brain triggers and organizes your movements so your actions are smooth and efficient. Most of this happens without you thinking about it. Meet your brain. Origin of genius. Compared to other animals, the human brain has a much bigger cerebrum shown in orange above. This is what makes us intelligent, because we use the cerebrum for conscious thoughts. Mapping the brain. Your brain is the most complex organ in your body, a spongy pink mass made up of billions of microscopic nerve cells linked together in an electronic network. Each part has its own job, but it is the biggest part, the cerebrum, that is responsible for your thoughts and actions. Galen of Pergamon. A Greek surgeon named Galen of Pergamon was one of the first people to suspect that the brain was an important organ and that it controlled memories and emotions. Galen lived between 129 and 200 CE in what is now Turkey, where he treated the gory injuries of gladiators. Your brain is 77% water. Cerebrum. The biggest part of the brain controls all our conscious actions and thoughts, analyzes sensory data and stores memories. Up to 2.1 liter of blood flows through your brain every minute. Blood supply. The brain needs a constant supply of oxygen to fuel its activities. This is delivered in the blood via the body's circulatory system of arteries, veins, and capillaries. Around 1/5 of the body's entire quota of oxygenated blood is reserved for the brain. Left brain. The cerebrum is divided into two halves, connected by the bridge of nerve fibers. For some functions, each half is wired to the opposite side of the body, but other skills and thought processes are controlled by only one half of the brain. Left brain. Left brain skills. The left side of your brain is responsible for the more logical, rational aspects of your thinking as well as your verbal skills. Language. Your ability to express yourself in words is usually controlled by the frontal lobe of the left cerebral hemisphere. Scientific thought. Logical scientific thinking is the job of the left side of the brain, although most science also involves being creative. Rational thought. Thinking and reacting in a rational way appears to be mostly a left brain activity. It allows you to analyze a problem to find an answer. Mathematical skills. Studies show that the left side of the brain is much better at dealing with numbers than the right side, and it is responsible for mathematical skills. Writing skills. Like spoken language, writing skills that involve organizing ideas and expressing them in words are largely controlled by the left hemisphere. Right brain. Right brain skills. The right side of your brain seems to be the focus of your more creative thoughts and emotional, intuitive responses. It is also important for spatial awareness. Special skills. Your ability to visualize and work with three-dimensional shapes is strongly linked to the right side of your brain. Art. Visual art is related to spatial skills, and the right side of your brain is probably more active when you're drawing, painting, or looking at art. Imagination. Your creative imagination is mostly directed by the right hemisphere, although expressing that imagination involves left brain skills. Insight. Those moments of insight when you connect two very different ideas probably come from the right half of your brain. Music. Like visual art, music involves a lot of right brain activity, but trained musicians also use their left brains to master musical theory. crossed wires. The left side of each eye is connected to the left side of your brain, but it picks up data from the right side of your head, the right visual field. Each side of the brain processes images from the other side of the head. Each side also controls the muscles of the opposite hand. Right-handed world. The left brain controls the right hand, and since most people are right-handed, this suggests that the left brain is usually dominant. So the left-handers use their right brain skills more. There is no proof of this, and many left-handers have no trouble using language and logic. Taking sides. Most people are either left or right-handed, but did you know that you can also have a dominant foot and a preferred eye? In both physical and mental tasks, the left and right sides of your brain are far from equal, and it is very rare for someone to be able to use both hands or feet equally well. Try the following test to find which side you are on. Eye motion. Look straight at the nose of the girl in each of these pictures. In which one do you think she looks happier? Most people find that she looks happier in the bottom image, which shows her smiling on the left side of the picture. This is because information from your left visual field gets processed in your brain's right hemisphere, which is also dominant for interpreting emotions. Best foot forward. The easiest way of finding which of your feet is dominant is to kick a soccer ball, but you usually take the first step of a flight of stairs with your stronger foot too. Your preferred foot may not be on the same side as your dominant hand. You can be left-footed and right-handed at the same time. Try doing things with the opposite hand to normal, such as switching the hand that you hold your fork with or putting your watch on the other arm. This forces your brain to learn new ways of doing things and creates more connections between the two sides of your brain. I see you. To discover which is your dominant eye, hold up your index finger to eye level and look past into the distance. Then close each eye, one at a time. You will see that with your weaker eye, your finger will appear to jump, whereas with your stronger eye, it will stay in place. Your stronger eye figures out that the position of things, while the weaker eye helps with depth perception. Trick your brain. This exercise reveals how your brain sometimes tricks you into taking shortcuts. First, draw this upside-down picture of a face. Then, turn the face the right way up and draw it again. When you compare the two pictures, you may be surprised to find that the upside-down version is the most accurate. The left side of your brain assigns simple shapes to common objects. For example, an almond shape for an eye. So if you draw a face the right way up, you probably draw the features based on what you think they look like rather than what you see. When you look at a face upside down, however, The right side of your brain works harder to understand the unfamiliar image, and you draw the shapes and lines you actually see. Having one hand as strong as the other can give you an advantage in some sports. In baseball, for example, an ambidextrous hitter can switch hands to strike the balls from the best side. Nerves and neurons. Your brain is connected to a nerve network that extends to every part of your body. The system is like a tree with many branches and twigs sprouting from the spinal cord that links them to the brain. The nerves consist of bundles of cells called neurons, which also form the tissue of the brain itself. Nervous system. The small nerves that reach every corner of your body are called the peripheral outer nervous system. They gather data from your senses and pass it to the central nervous system, the spinal cord and brain, where it is processed. Instructions are then sent through the peripheral nervous system to your organs and muscles. Your brain is only 3% of your body weight, but consumes 17% of your body's total energy. The axons of some neurons are more than 3 feet or 1 meter long, making them the biggest cells in the human body. Branching cells. The body is made up of many different types of cells. Each is basically an envelope of fluid containing a nucleus that controls what it does. Neurons are cells with an unusual form because they have branching filaments called dendrites that receive information from other neurons. The longest filaments or axons form the main nerve fibers of the body. Tangling nerves. The long axon of a neuron is like a wire that conducts electrical signals. At one end is the dendrite, which receives signals from other neurons and passes them down the cell body. These signals release chemicals that trigger more electrical impulses, which pass out and onto other neurons are the synaptic knob at the other end of the axon. Send and receive. Different neurons have their own jobs. Sensory neurons pick up signals from your senses, while motor neurons deliver signals to your muscles. Some of this activity involves conscious thought, especially if you're engaged in a skilled activity, but a lot happens automatically, controlling vital functions like your heartbeat and breathing. Nerve network. Neurons link together to pass nerve signals to one another. This activity is most intense in the brain, where around 100 billion neurons form a complex network resembling the electronic circuits of a computer. This network processes the data gathered by your senses, stores it in your memory, and gives you the ability to think. Reflex. If you touch the sharp spine of a cactus, a pain signal shoots up a nerve in your arm to your spinal cord, which instantly triggers a nerve impulse that pulls your hand away. The impulse short circuits the central nervous system to cause an automatic reaction called a reflex. Your brain is not involved, although it is kept informed. You move before you realize it. You could fit 13,000 neurons on the head of a pin. Electrical nerve impulses shoot along the long axons of neurons at 400 kilometers per hour. Brain waves. Your brain is an electrical device. Simple electrical sensors can detect the tingling of brain cells as they are stimulated by other brain cells, and they show this activity on a display in the form of waves. These waves take different shapes depending on your state of mind. Scientists can also use various types of scanners to produce images of the brain at work. These show which areas are active when dealing with different tasks. Thinking and dreaming. Different mental states generate different types of brain waves. An alert thinking state creates a fast but shallow beta wave, while a relaxed state generates a slower but deeper alpha wave. An even slower theta wave indicates drowsiness, and sleep produces a delta wave, which is slower still. The slowest, deepest delta waves indicate deep, dreamless sleep. Hans Berger. Brain waves were first recorded by German psychologist Hans Berger in 1924 using silver wires attached from the head to a device that showed the waves. He named his first recordings alpha and beta waves, after letters of the Greek alphabet. Since then, scientists have recorded delta waves, gamma waves, and theta waves. Bright sparks. Modern scanning techniques enable researchers to see inside the brain as it deals with different tasks. The positron emission tomography scan on the left shows a three-dimensional cutaway image of a man's brain while he is having a conversation. The areas responsible for listening and speaking appear to light up in brighter colors as they become more active. Paul Broca. French physician Paul Broca discovered the area of the brain that controls speech. After a male patient of his who could not speak died in 1861, Broca examined his brain and found that the region now called Broca's area was damaged. Other areas of the brain have been identified in the same way. No one has discovered a part of the brain that gives a person a sense of self or acts as the site of consciousness. Mapping the brain. By combining modern scanning techniques with studies of brain anatomy, science have mapped the areas of the brain responsible for tasks such as seeing, hearing, speaking, and movement. But consciousness and learning do not seem to be related to particular areas. They may involve activity in many parts of the brain at once. The cerebral cortex enables you to think and accounts for 80% of your brain. I'm Maria Doneva and I am part of a special educational program, Young and Adult Geniuses, created and in ownership of AQ Excellence Company, and this is a small part of an interesting book called How to Be a Genius, written by John Woodward. What is a genius? We all know that we mean by a genius someone who is super intelligent or has amazing skills. But are these people born with these qualities or do they develop them? It turns out that while being smart is very important, a lot of also depends on originality, determination, support, and hard work. Original thinking. Italian astronomer Galileo Galilei, 1564-1642, lived at a time when most people had strange ideas about how the universe worked. His genius was to study everything with fresh eyes and come up with theories based on observations and experiments. In the process, he invented modern science. Mad scientist. Ancient Greek philosopher Pythagoras is famous for his mathematical theories. Yet he was also eccentric, remembered for forbidding his students from eating beans. Many geniuses have odd habits, usually because they are so absorbed by their work that they neglect everything else. They often become known as mad scientists. Geniuses' ideas are not always popular. Galileo got into serious trouble for promoting the idea that Earth was not the center of the universe. This one is very important. There is a theory that it takes 10,000 hours of work to be an expert at anything. That is around 10 years of practice. Determination. Born in Poland in 1867, Maria Curie was determined to be a scientist, even though such a career was not considered suitable for a woman in the 80s. She fought poverty and prejudice to win 2 Nobel Prizes for her pioneering work on radioactivity. Child prodigy. Some people just seem to be born geniuses. Garry Kasparov was only 13 when he won the Russian Junior Chess Championship in 1976, and he became the youngest ever world champion in 1985. He had a natural talent, but he worked hard to make the most of it. Broad view. Some geniuses do one thing extremely well, but others excel at many things. Thomas Jefferson, the main author of the U.S. Declaration of Independence in 1776, was a philosopher, archaeologist, architect, and inventor, as well as a politician who became President of the United States. Encouragement. American sisters Venus and Serena Williams are among the greatest of all tennis players. They showed amazing talent from a young age, but they owe a lot of their success to their parents, who coached and encouraged them to build on their skills. Follow us in the next few days for more interesting information. Thank you.